And now in this lecture we'll find out the radius of the small circle. In the drawing we have a small circle that is inscribed by a semicircle, and we know that line segment DB equals to 4 units, line segment CD equals to 3 units, angle CDB, this angle is a right angle, it is equal to 90 degrees, and we want to find out the radius of this circle that is inscribed by this semicircle. Okay, so first of all we'll do a construction. We'll complete this semicircle to a circle. So we completed this semicircle to a circle. In the next step, we will extend line segment CD until it touches the circle. And we will define the touching point of the extended line segment CD and this circle as point E. So we extended the straight line CD by straight line, and when you extend a straight line by a straight line, when you extend a straight line by a straight line, the result must be a straight line also. So when you extended the straight line CD by CD, we got line segment CE that is also must be a straight line. So if we focus on this side of the straight line CE at point D, then the sum of the angles at this side of CE at point D must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at point D at this side of CE? We have here 90 degrees and also angle EDB. So here 90 degrees plus the size of angle EDB. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we subtract 90 degrees from this equation, and we get that the angle EDB, the missing angle EDB, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So angle EDB is a right angle. This angle is a right angle, it is equal to 90 degrees. Okay, so actually when we did the construction and when we created a circle from this semicircle, we actually created a second semicircle. This semicircle is the mirror image of the original semicircle. Okay, and we know that angle CDB equals to 90 degrees and also angle EDB, this angle is also equals to 90 degrees. And actually ED, line segment ED is also mirror image of the original line segment CD. Okay, and because of the fact that ED is a mirror image of CD, they must be equal in their lengths. Those two line segments must be equal in their lengths, and they will be opposite in their directions, but they must be equal in their lengths. That is to say, CD equals to DE, CD equals to DE by symmetry. By symmetry, that is to say, DE is the mirror image of CD, and when you look at a mirror, you see yourself with your exact dimensions, but in the opposite direction. When you look at a mirror, you see yourself exactly with your dimensions, with your exact height, and all the other things exactly like you are, but you are in the opposite direction. Therefore, CD will be the same length of DE, because DE is the mirror image of CD, and therefore they will be equal to their lengths, but they will be in the opposite direction. For that reason, CD equals to DE by symmetry. That is to say, DE is the mirror image of CD, therefore the lengths of those two line segments must be equal to each other, but they are in opposite sides. But their lengths must be equal to each other. That is to say, CD equals to DE, because DE is the mirror image of CD, and the mirror image is always the same length as the image itself. That is to say, CD equals to DE. But we know it is given us the question that CD equals to 3 units. So okay, we can write down that CD equals to 3 units. And from this equation, 3 equals to CD equals to DE, we will derive that DE is also equals to 3 units. DE is also equals to 3 units, so we can write down here that DE equals to 3 units. Okay? In the next step, I will present to you a new rule that is related to two chords that intersect with each other inside a circle. Okay? So that will be rule number 1. According to rule number 1, if two chords intersect with each other inside a circle, then the following equation is true. So in this rule number 1, we are talking on two chords. This is chord AB, chord AB. This is chord AB that intersects with chord CD. This is chord CD. Again, chord AB. This is chord AB that intersects with the red chord CD at point O. Point O is the intersection point of chord AB with chord CD. So if this is the data that has been given to us, then according to rule number 1, we will get that AO times OB AO times OB equals to CO times OD. I will repeat again. According to rule number 1, if chord AB intersects with chord CD at point O is the intersection point of chord AB with chord CD, then according to rule number 1, we will get that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Okay? So we can actually implement rule number 1 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord CE. Again, chord AB intersects with chord CE at point D. Point D is the intersection point of chord AB with chord CE. So I write it down. In our original drawing we have chord AB intersects with chord CE, this chord, at point D. Point D is the intersection point of chord AB with chord CE. I repeat again. Chord AB intersects with chord CE at point D. Therefore, according to rule number 1, AD times DB will be equal to CD times DE. I will repeat again. According to rule number 1, AD times DB will be equal to CD times DE. Okay? So here AD is the missing line segment, so we will leave it as it is. DB equals to 4 units according to what is given us in the question, so we will substitute DB by 4. And it is equal to CD. CD equals to 3 units, according to what is given us in the question, times DE. We have already found out that D equals to 3 units. So in conclusion, we found out that according to rule number 1, AD times 4 equals to 3 times 3. 3 times 3 is 9. So according to rule number 1, we found out that 4 times AD equals to 9. Here we will divide this equation by 4 and we will get that AD equals in its length to 9 over 4 units. So we can write here that AD equals to 9 over 4 units. Okay, and we know that AB is the diameter of the circle and also the diameter of the semicircle. So AB is the diameter of the circle and the semicircle, and we know that if we divide the diameter to 2, we get the radius of the circle and the semicircle. So we define the radius of the circle and the semicircle as capital R. So I found out that capital R, that is the radius of the circle and the semicircle, it is equal to AB over 2. Okay? But what is the length of AB? The diameter AB, according to this drawing, it is equal to AD plus DB. AD plus DB equals to AB, and if we divide it by 2, we get the radius of the circle and the semicircle. And we have already found out that AD equals to 9 over 4 units, and DB equals to 4 units according to what is given us in the question, all divided by 2. It is the radius of the circle and the semicircle. So here we have 9 over 4 plus 4. Here we will multiply 4 by 4, and we will also divide it by 4 in order to have a common factor with 9 over 4. And we get that 9 plus 4 over, it is actually, we multiplied 4 by 4, so 4 times 4 is 16. So it is 16 plus 9 over 4 over 2 equals to the radius of the circle and the semicircle. So here 9 plus 16 is 25 over 4 over 2. Here we remove 2 to the denominator, and we will get that the radius of the semicircle and the circle itself, it is equal to 25 over 2 times 4. 2 times 4 is 8. So in conclusion, we found out that the radius of the circle and the semicircle equals to 25 over 8 units. Here, capital R, that is the radius of the circle and the semicircle, it is equals to 25 over 8 units. Okay? So we found out the radius of the circle and the semicircle. In the next step, we will define the center of this circle and the semicircle as point P. And we will also define the center of this small circle as point Q. Okay? So, what is the length of the small line segment DP? Here, the length of the small line segment DP, from the drawing, it is very easy to see that DP the length of the small line segment DP will be equal to DB minus PB. DB minus PB. I'll repeat again. Here, DP equals to DB minus PB. DB minus PB equals to DP. Again, DP equals to DB minus PB. Okay, it is very simple, very easy to see it from the drawing. So DP equals to DB, DB is 4 units, minus PB. What is the definition of line segment PB? We know that line segment PB starts from point P point P is the center of the circle and also the semicircle, and point B is a point of the circle itself. And this is exactly the definition of a radius. That is to say, BB is the radius of the big circle that is equal to capital R. So in conclusion, we found out that dP equals to 4 minus capital R. That is to say, dP equals to 4 minus capital R, and we've already found out that capital R equals to 25 over 8 units. So here we will multiply 4 by 8 in order, and then we'll divide it by 8 in order to have a common factor with 25 over 8. And we get that dP, it is equals to 4 times 8 is 32 minus 25 over 8. 32 minus 25 is 7 over 8. So we found out that dP equals to 7/8. dP equals to 7/8. So we can write here that dP equals to 7/8. In the next step, from point Q, we will draw the radius to the point of tendency. Here, this is point O. Point O is the point of tendency of tangent CD with this small circle. I will repeat again. Point O is the point of tendency of tangent CD with this small circle. And point Q starts from the center of the small circle and ends at point O, that is the point on the small circle itself. This is exactly the definition of a radius. So QO is the radius of the small circle. We will define the radius of the small circle as R, small r. Small r is the thing that we are looking for in this lecture. We want to find out the radius of this small circle that is equal to small r. So here we have the radius QO that is equal to small r, that is drawn to point O, that is the point of tendency of tangent CD with this small circle. And whenever you have a radius, like in this drawing QO, that is drawn to the point of tendency, that is to say it is drawn to point O, that is the point of tendency of tangent CD with this small circle, then the tangent CD must be perpendicular to that radius QO. So CD is perpendicular to QO, that is to say this angle must be equal to 90 degrees, and this angle will be also equal to 90 degrees. Again, because of the fact that the radius QO, it is drawn to the point of tendency, that is to say it is drawn to point O, that is the point of tendency of tangent CD with this small circle, then the tangent CD will be perpendicular to the radius OQ. So CD is perpendicular to OQ. If CD is perpendicular to OQ, that means that this angle equals to 90 degrees and this angle must be also equal to 90 degrees. And likewise, from the center of this small circle Q, we'll draw the radius that is drawn to the point of tendency. We will define the point of tendency of tangent DB with this small circle, as point M. I repeat again, we will define the point of tendency of tangent DB with this small circle as point M. QM is the radius of this small circle, that is to say it is equals to R, and we have the radius QM that is drawn to the point of tendency, that is to say the radius QM, it is drawn to point M, that is the point of tendency of tangent DB in this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, tangent DB will be perpendicular to the radius MQ. So DB is perpendicular to MQ, that is to say this angle equals to 90 degrees, and this angle must be also equal to 90 degrees. Again, whenever you have a radius that is drawn to the point of tendency, like in this drawing, the radius QM, it is drawn to point M, that is the point of tendency of tangent DB with this small circle, then the radius MQ will be perpendicular to the tangent DB. QM is perpendicular to DB, that is to say this angle equals to 90 degrees, and this angle must be also equal to 90 degrees. So in quadrilateral OQDM, this quadrilateral, we have 1, 2, 3 right angles. This is a right angle. It is given us in the question that this is a right angle, that is to say angle CDM equals to 90 degrees according to what is given us in the question. So in quadrilateral OQDM we have 1, 2, 3 right angles. I write it down. I repeat it, quadrilateral OQDM. We have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, this is actually angle OQM, this angle, in total the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So 270 degrees plus the size of angle OQM must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that the missing angle OQM is equal to 360 degrees minus 270 degrees, it is 90 degrees. So angle OQM is a right angle, it is equal to 90 degrees. So we can write here that angle OQM, this angle is a right angle, that is to say it is equal to 90 degrees. So actually in quadrilateral OQDM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral OQDM as a rectangle. Okay? Quadrilateral OQDM is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle OQDM, in this rectangle, OQ must be equal to DM. In rectangle OQDM, OQ must be equal to DM. Because those sides are 2 opposite sides and they must be equal to each other, because in rectangle the opposite sides are equal to each other. So OQ must be equal to DM. But we have already found out that OQ is the radius of the small circle, that is to say it is equal to small r. So we have from this equation r equals to OQ equals to dm, we will derive that dm is also equals to r. dm is also equals to r. Okay? So we can write here that dm is equal to r, that is the radius of the small circle. Okay, and what is the length of side PM? The length of side PM from the drawing, it is very easy to see that PM equals to dm minus dp. Okay, I repeat again, PM equals to dm minus dp. So dp dm minus dp equals to PM. Okay, dm minus dp equals to PM. Here, PM equals to dm minus dp. So here actually PM equals to dm. We already found out that dm equals to r, it is the radius of the small circle, so dm equals to small r minus dp. We already found out that dp, the small line segment dp, equals to 7/8. So actually, in conclusion, we found out that the length of line segment PM, it is equals to r minus 7/8. R minus 7/8 is the length of segment line PM. So we can write here that PM equals to r minus 7/8. In the next step, I will present to you a new rule that is actually rule number 2. According to rule number 2, if two circles have an internal notch between them, that is to say they are touching each other internally, then the straight line that connects the two centers together, the straight line or the straight line that connects their centers passes through the launch point. Passes through the launch point of the two circles. and the launch point, it is point of contact or point of tendency. Or the touching point between those two circles. So I repeat on rule number 2 again. According to rule number 2, if two circles have an internal launch between them, that is to say they are touching each other internally, then the straight line that connects the straight line that connects their centers passes for the launch point. That is to say, it passes for the touching point between those two circles, or the straight line that connects their centers touches for the touching point of those two circles, or the launch point. Okay, it is the same. So here, what is the meaning of rule number 2? The meaning of rule number 2 is that here we have the big circle and this small circle have an internal launch between them. That is to say, they are touching each other internally at this point. We define the touching point of those two circles, or the launch point, as point S. So I write here that point S is the launch point of the big circle with the small circle. So you can call point S launch point, or point of tendency, or touching point. All those three expressions that I mentioned are the same. So here I wrote down that point S is the launch point of the big circle with the small circle. So the small circle is located inside the big circle, and those two circles are touching each other internally at point S. So this kind of launch between the two circles is defined as internal launch. So according to rule number 2, if two circles have an internal launch between them, those two circles have an internal launch between them because the small circle is located inside the big circle, and those two circles are touching each other internally at point S. Point S is the launch point between the big circle and the small circle. And according to rule number 2, the straight line that connects their centers, here point Q is the center of the small circle. Point P, this point, is the center of the big circle. And the straight line that connects their centers, here it is PQ. I will repeat again. PQ is the straight line that connects their centers together, because point P is the center of the big circle and point Q is the center of the small circle. And according to rule number 2, this straight line PQ, passes for the center, passes for the launch point. Point S is the launch point, that is to say, PQS is one straight line. The straight line PQ passes through point S, that is to say, all the 3 points P, Q, and S are located on the same straight line. That is to say, PQS is one straight line. Okay? So, I'll repeat again. that those two circles, the small circle and the big circle, have an internal knot between them at point S. That is to say, they are touching each other internally at point S. Point S is the launch point between them. In this case, the straight line that connects their centers, that is to say PQ, passes through point S. That is to say, PQS is one straight line. Okay, PQS is one straight line. And what is the definition of PQ? The definition of PQ, P is the center of the big circle. No, actually we are talking about PS. What is the definition of PS? P is the center of the big circle. S is a point on the big circle itself. And this is exactly the definition of a radius. That is to say, PS is the radius of the big circle that is equal to capital R. And we have already found out that capital R equals to 25/8. So PS is the radius of the big circle that is equal to 25/8 units. What is the definition of QS? Q is the center of the small circle. Point S is a point on the small circle itself. And this is exactly the definition of a radius. That is to say, QS equals to small r, that is the radius of the small circle. Okay? So PS equals to capital R. QS equals to R. Therefore, PQ, what is the PQ? What is the length of line segment PQ? The length of line segment PQ, it will be equal to here, the length of this line segment PQ equals to PS minus QS. PS minus QS equals to PQ. Repeat again. PQ equals to PS minus QS. So PQ equals to PS. PS is the radius of the big circle, that is to say it is equals to capital R, minus QS. We have already found out that QS equals to small r. So in conclusion, we found out that the length of line segment PQ, it is equal to capital R minus small r. But we have already found out that capital R equals to 25/8. So we substitute capital R by 25/8. And we get that PQ, in conclusion, it is equals to PQ equals to 25/8 minus small r. Okay? PQ equals to 25/8 minus small r. Okay, now we actually found out all the sides of the right green triangle PQM. Therefore, we will implement the Pythagoras theorem of the right green triangle QPM, and we will find out the only missing variable, that is small r, that is the thing that we want to find out in this lecture. We want to find out the radius of this small circle that is equal to small r. So I will copy the right triangle PQM in a new page, and we will implement the Pythagoras theorem on the small right triangle PQM. Okay? We have already found out that PQ equals to 25 over 8 minus small r. We have already found out that PM equals to R minus 7/8. And we have already found out that QM equals to R, small r, that is to say it is the radius of the small circle. Okay, so here we have triangle QPM that I copied from the original drawing. Now we will implement the Pythagoras theorem. By PT is the progression for Pythagoras theorem. We get that according to the Pythagoras theorem of this right triangle QPM, according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So here, the square of the hypotenuse is QP, therefore the square of the hypotenuse is QP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to QM squared plus PM squared. Okay. We have already found out that QP equals to 25 over 8 minus small r. So we will square it in order to get QP squared. And we have already found out that QM equals to small r, so QM squared is small r squared plus PM squared. PM equals to small r minus 7/8, so PM squared will be equal to small r minus 7/8 squared. So here we will open the brackets on both sides of this equation number 1. Here, according to the algebraic identity, a minus b squared equals to a squared plus b squared minus 2 times ab. Therefore, according to this, the algebraic identity that I mentioned, 25 over 8 minus r squared, it is equals to 25 over 8 squared. That is 25 squared, that is 625, over 8 squared, that is 64, plus b squared. B squared is r squared, minus 2 times 25 over 8 times r, and in the other side of the equation we have r squared plus r minus 7/8 squared, that is r squared plus 7/8 squared. 7/8 squared is 7 squared, that is 49, over 8 squared, that is 64, minus 2 times r times 7/8. So first of all, here we have r squared on both sides of the equation, so r squared will get cancelled. So according to equation number 1, we get that 625 over 64. Here we have minus 2 times 25 times r over 8. So we divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, so minus 2 will get cancelled. And in the numerator we left only with minus 25r. In the denominator we have 8, and 8 over 2 is 4. So in conclusion, this expression equals to minus 25r over 4. That is equal to, here we have r squared plus 49 over 64. Here we have the expression of minus 2r times 7 over 8. So here we'll divide both the numerator and the denominator by 2. Minus 2 over 2 is minus 1, so minus 2 will get cancelled. So in the numerator we left only with minus 7r, and in the denominator we have 8, and we must divide 8 by 2 because we divided the numerator and the denominator by 2, so 8 over 2 is 4. So in conclusion, this expression equals to minus 7r over 4. Okay, so here we will multiply this expression by 64, and we will get that according to equation number 1, (625 times 64 over 64 is 625), and we have minus 64 over 4 is minus 16. Okay, so this expression in conclusion, it is equals to, in total it is equals to minus 16 times 25r, and it is equal, in the other side of the equation we have r squared times 64 is 64r squared, and we have here 49 over 64 times 64 is 49, and we have here minus 64 over 4 is minus 16. So this expression in total it is equal to minus 16 times 7r. Okay. So here, according to equation number 1, we will get that (625) minus 16 times 25r is minus 100r, minus 400r. Minus 16 times 25r equals to minus 400r. That is equal to 64r squared plus 49 minus 16 times 7r is minus 112r. Okay, so here we found out that 625 minus 400r equals to 64r squared plus 49 minus 112r. Here we will add 100r, 400r to this equation, equation number 1. So here 625 plus 400r minus 400r is 0. So in this side of the equation we left only with 625. In the other side of the equation we have 64r squared plus 49, and we have 400r minus 112r, it is 288r. So in conclusion, we found out that according to equation number 1, 625 it is equal to 64r squared plus 49 plus 288r. Here we will subtract 625 from this equation, equation number 1, and we get that 625 minus 625 is 0, and it is equal to 64r squared plus 288r, and here we have 49 minus 625, it is equal to minus 576. So in conclusion, we got the quadratic equation according to equation number 1, 64r squared plus 288r minus 576 equals to 0. This is the quadratic equation. We divide this the quadratic equation to 32, and we get that according to equation number 1, (64r² over 32 is 2, so this expression equals in total to 2r². 288 over 32 is 9, so this expression equals in total to 9r. And here we have minus 576 over 32, it is equals to minus 18. And all equals to 0. So we have here the quadratic equation that 2r² plus 9r minus 18 equals to 0. In this quadratic equation, the coefficient A equals to 2, the coefficient B equals to 9, and the coefficient C equals to minus 18, and the variable that we are looking for in this quadratic equation is r, so x equals to r. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we're looking for. Okay, and in our specific expression, the variable that we are looking for is x, so x equals to r. So we substitute x by r, and we get that r equals to minus b. b equals to 9, so minus b is minus 9. Plus minus square root of b squared. b equals to 9, so b squared is 9 squared, that is 81. Minus 4 times a is 2, times 18, times c, that is minus 18. All divided by 2a. a is 2, so 2 times 2 is 4. So here we found out that r, the radius of the small circle, it is equals to minus 9 plus minus, and here we have square root of 81 minus 18 times 2 is minus 36, and minus 36 times minus 4 is plus 144. So inside the root we left only with 81 plus 144, all divided by 4. Okay, so actually we found out that r it is equal to minus 9 plus minus 81 plus 144 is 225. So inside the root we left only with 225 divided by 4. So here r equals to minus 9 plus minus the square root of 225 is 15, all divided by 4. So here we have two solutions that are possible for r, that is the radius of the small circle. R will be equal to either minus 9 minus 15 over 4. Minus 9 minus 15 is minus 24, and minus 24 over 4 is minus 6. So we found out that r equals to minus 6. That is a negative number, but r is the radius of this small circle, or r is the length of the radius of the small circle. So r is a length, r is a length, and as a length it must be a positive number. Okay, it must be a positive number. Therefore, it can never be equal to minus 6, that is a negative number. So we cancel the solution, and we left only with the second solution for r, that r, it is equal to minus 9 plus 15 over 4. Minus 9 plus 15 is 6 over 4, so r equals to 6 over 4. We will divide both the numerator and the denominator of this side of the equation by 2. 6 over 2 is 3, and 4 over 2 is 2. So in conclusion, we found out that r equals to 3 over 2 units, or can represent it also as 1.5 units. Okay, so I repeat again that the radius of the small circle, here the radius of this small circle, it is equal, that is to say small r, it is equal to either 3 over 2 units, or we can say it is 3 halves, or we can present it also as 1.5 units. That is the answer to the question. In the next step I will summarize the lecture. So actually we have in this question a circle that is inside a semicircle. We know that side CD equals to 3 units, side DB equals to 4 units, angle CDB equals to 90 degrees, and we want to find out the radius of this small circle. So actually, in order to find out the radius of this small circle, we did a construction. We actually completed this semicircle to a circle. So we have here a circle, and in the next step we extended the straight line CD by a straight line until it touches the circle at point E. Okay? Point E is the touching point of the extended straight line CD with this circle. So actually we extended the straight line CD by a straight line, and we got line segment CE. When we extend the straight line by straight line, the result must be also straight line. So CE must be a straight line, and we have the rule that the sum of the angles on one side of the straight line must be equal to 180 degrees. So if we focus on this side of the straight line CD at point D, then the sum of the angles in this side of CE at point D must be equal to 180 degrees. So which angles we have at point D? We have here 90 degrees plus angle EDB. In total, the sum of those two angles must be equal to 180 degrees. Here, 90 degrees plus angle EDB must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we will get that angle EDB equals to 180 degrees minus 90 degrees, it is 90 degrees. So the missing angle here, this angle, it is a right angle, it is equal to 90 degrees. Okay, so actually, when we completed the semicircle to a circle, we did this construction, we created another semicircle. Any circle is composed of two semicircles. And the second semicircle that we created is a mirror image of the original semicircle. I repeat again, this semicircle that we created is the mirror image of this original semicircle. Okay? And then we know that this angle equals to 90 degrees and this angle also equals to 90 degrees. And we extended the straight line CD by straight line, we created line segment DE. And here, actually, line segment DE is a mirror image of line segment CD. And when you create a mirror image of any object, the length of the mirror image and the original image must be equal to each other. So the length of CD must be equal to DE, and the only thing that is changing when you created the mirror image is that the direction of the mirror image is the opposite sides of the direction of the original image itself. When you look at a mirror, you see yourself exactly with the original dimensions, exactly with few exact dimensions, but in the opposite sides. And here CD must be equal to DE in its length, but it is in the opposite sides. Okay, because of the fact that DE is the mirror image of CD, they must be equal in their lengths. So here CD, here we have CD is equal to DE by symmetry. That is to say, DE is the mirror image of CD, and always the mirror image is equal to the original image itself, but the direction is the opposite direction. Okay, CD is in the opposite direction of DE, but the lengths of CD and DE are equal to each other. So CD equals to DE by symmetry, because DE is the mirror image of CD, and the mirror image is also always in the same length of the original image itself. So CD equals to DE by symmetry, but it is given us the question that CD equals to 3 units. So we can write here that CD equals to 3 units, and from this equation 3 equals to CD equals to DE, we will derive that DE is also equals to 3 units. Here DE is also equals to 3 units. As I already said, the length of line segments CD and DE, they must be equal to each other in their lengths. And the only difference between those two line segments is the direction. They are in the opposite direction, but they are equal to each other in their lengths. Okay, in the next step I presented to you rule number 1. According to rule number 1, if two circles intersect with each other inside the circle, then the following equation is true, that AO times OB equals to CO times OD. So we have here chord AB that intersects with chord CD, the red chord at point O. Point O is the second point of chord AB with chord CD. Therefore, according to rule number 1, we will get that AO times OB equals to CO times OD. Here, AO times OB equals to CO times OD. And we actually can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AB. Chord AB intersects with chord CE at point D. Again, chord AB intersects with chord CE at point D. Point D is the intersection point of chord AB with chord CE. Therefore, I'll repeat again, chord AB intersects with chord CE at point D. Point D is the intersection point of chord AB with chord CE. Therefore, according to rule number 1, we get that AD times DB equals to CD times DE. Again, AD times DE, AD times DB equals to CD times DE. Okay, AD times DB equals to CD times DE according to rule number 1. Okay, AD is the missing line segment, BD equals to 4 units, it is given as the question, CD equals to 3 units, it is given as the question, and we have already found out that DE is also equals to 3 units. So in conclusion, we found out that AO times 4 equals to 3 times 3, 3 times 3 is 9. So in conclusion, we found out that 4 times AD equals to 9. We divided this equation by 4, and we found out that the missing line segment AD equals to 9 over 4. Here AD equals to 9 over 4. And AB is the diameter of the semicircle, that is also the diameter of the circle itself. And we know that if we divide the diameter into 2, we will get the radius. The diameter that is AB over 2 is the radius of the circle, that is also the radius of the semicircle. We define the radius of the circle and the semicircle as capital R, therefore the diameter over 2 equals to the radius, that is capital R, according to our definition. And the length of AB equals to AD plus DB. Again, AB equals to AD plus DB. We already found out that AD equals to 9 over 4, and dB equals to 4 units, it is given us the question. And if we divide it by 2, we get the radius of the circle, that is also the radius of the semicircle. Here, we multiplied 4 by 4, and then we divided by 4 in order to have a common factor with 9 over 4. 4 times 4 is 16, so in the numerator we have 16 plus 9 over 4 over 2. 16 plus 9 is 25, 25 over 4 over 2. So we moved 2 to the denominator and found out that R, the radius of the circle, that is also the radius of the semicircle, equals to 25 over 2 times 4. 2 times 4 is 8, so we concluded and found out that the radius of the semicircle and also the radius of the circle itself equals to 25 over 8 units. Okay, here the radius, the radius of this circle is equal to 25 over 8 units. So we defined the center of this circle and also semicircle as point P, and we defined the center of the small circle as point Q. So here AP equals to PB equals to the radius of this circle, and that is also the radius of the semicircle, that is equal to 25 over 8. And what is the length of line segment DP? The length of the small line segment DP equals to DB minus PB. Again, DP equals to DB minus PB. DB equals to 4 units according to what is given as the question. And PB, what is PB? P is the center of the big circle. B is the point of the big circle itself. And this is exactly the definition of a radius. That is to say, PB equals to capital R. So here, DB equals to 4 and PB equals to capital R. So in conclusion, we found out that DP equals to 4 minus capital R. But we have already found out that capital R equals to 25 over 8. So we can substitute capital R by 25 over 8. We did it and we got that DP equals to 4 minus 25 over 8. Okay. Here we multiplied 4 by 8 and then we divided by 8 in order to have a common factor with 25 over 8. So here 4 times 8 is 32, so we have here 32 minus 25 over 8. 32 minus 25 is 7, so in conclusion found out that DP, the small line segment DP, is equals to 7/8. So here DP, the smallest line segment, equals to 7/8. Okay? Then from the center of this small circle, that is actually point Q, we draw the radius that is drawn to the point of tendency. In this case, the radius QO of the small circle is drawn to point O, that is the point of tendency of tangent CD with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, tangent CD will be perpendicular to the radius OQ. CD is perpendicular to OQ. It means that this angle equals to 90 degrees and this angle equals to 90 degrees. According to the rule that a tangent to a circle is perpendicular to the radius drawn to the point of tendency. And here, in the next step from point Q, we draw the radius QM that is drawn to the point of tendency, that is to say the radius QM, it is drawn to point M, that is the point of tendency of tangent DB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent DB will be perpendicular to the radius MQ. So DB is perpendicular to MQ, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees, according to the rule that I have already mentioned. Okay, so actually, if we focus on quadrilateral OQDM, we have 1, 2, 3 right angles. In quadrilateral OQDM, we have 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle OQM. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle OQM equals to 360 degrees minus 270 degrees, it is 90 degrees. So the fourth angle, the missing angle, the fourth angle that is actually angle OQM is a right angle. Therefore, in quadrilateral OQDM, we have four right angles. And any quadrilateral that has four right angles must be at least a rectangle. So we will relate to quadrilateral OQDM as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle OQDM, in this rectangle, side OQ must be equal to side DM. OQ equals to side DM according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that OQ equals to small r. OQ equals to small r, so we can write here that OQ equals to small r, and from this equation r equals to OQ equals to OM, we will derive r equals to OQ equals to DM. We will derive that dm is also equals to small r. Here, dm equals to small r, that is the radius of the small circle. Okay? So what is the length? So we already found out that dp equals to 7/8 and dm equals to small r. And what is the length of pm? From the drawing it is very easy to see that pm equals to dm minus dp. Again, dm minus dp equals to pm. Here, pm equals to dm minus dp. dm, we just right now found out that dm equals to small r, and we have already found out that dp equals to 7/8. So in conclusion, we found out that pm equals to r minus 7/8. So we can write here that pm equals to r, small r minus 7/8. Then I presented to you rule number 2. According to rule number 2, if two chords have an internal length between them, then the straight line that connects between their centers passes through the launch point of the two circles. And the launch point is the point of tendency or the touching point of the two circles. Okay, so what is the meaning of rule number 2? The meaning of rule number 2 is that if two circles touch each other internally, then it is defined as an internal launch. The big circle touches this small circle at point S, and the small circle is located inside the big circle. That is to say, this is the definition of an internal launch. Those two circles have an internal launch between them at point S. Okay, so in the case of the internal launch between the circles, like in this case that those two circles have an internal launch between them at point S, then the distance between their centers, that is actually PQ. Why? Because P is the center of the big circle, Q is the center of the small circle. Therefore, PQ is the distance between the two centers, and the straight line that connects the two centers together is PQ. And that straight line PQ, according to rule number 2, passes through point S. That is the launch point between the two circles. That is to say, points P, Q, and S, all the 3 points P, Q, and S are located on the same straight line. PQS is one straight line, according to rule number 2. Okay? All the points P, Q, and S are located on the same straight line. Therefore, PQS is one straight line, according to rule number 2. So here, what is the definition of line segment PS? PS, point B is the center of the big circle. Point S is the point on the big circle itself. This is exactly the definition of a radius. That is to say, PS equals to the radius of the big circle, that is to say it is equal to capital R, that is 25 over 8. So PS is the radius of the big circle, that is equal to 25 over 8 units. Okay, and what is the definition of QS? Q is the center of the small circle. S is the point on the small circle itself. This is exactly the definition of a radius. That is to say, QS is the radius of the small circle that is equal to small r. And what is the length of line segment PQ? From the drawing it is very easy to see that PQ equals to PS minus QS. Again, PS minus QS equals to PQ. Here, PQ equals to PS minus QS. PS, we already found out that PS equals to the radius of the big circle, that is capital R. So PS equals to capital R, and SQ equals to small r, it is the radius of the small circle. So in conclusion, we found out that PQ equals to capital R minus small r. That is to say, PQ equals to capital R minus small r. So, but R equals to 25 over 8, capital R equals to 25 over 8, so we can substitute capital R by 25 over 8. We did it and we got that PQ equals to, in total, equals to 25 over 8 minus small r. So here PQ equals to 25 over 8 minus small r. Okay? So in the green triangle, we found all the sides. And the only missing variable in the green right triangle is r, small r. So we will implement the Pythagoras theorem on the small right triangle and then we find out the value of small r. We did it. Here, this is the right triangle QPM that I copied from the original drawing. We already found out that QM equals to small r, it is the radius of the small circle. We just right now found out that PQ equals to 25 over 8 minus small r, and we have already found out that PM equals to small r minus 7/8. We implemented the Pythagoras theorem in this triangle MPQ. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is PQ, so the square of the hypotenuse is PQ squared. And it is equal to the sum of the squares of the perpendiculars. This is to say it is equal to QM squared plus PM squared. So according to the Pythagoras theorem, we found out that QP squared equals to QM squared plus PM squared. We have already found out that QP equals to 25 over 8 minus r, so QP squared will be equal to 25 over 8 minus r squared. QM equals to r, so QM squared equals to r squared. PM equals to r minus 7/8, so PM squared equals to r minus 7/8 squared. So here we open the brackets on both sides of this equation, equation number 1. Here we have 25 over 8 minus r squared, that is 25 over 8 squared, that is 625 over 64, plus r squared minus 2 times 25 over 8 times r, and it is equal to r squared. And here r minus 7/8 squared equals to r squared plus 7/8 squared, that is 60, and that is 49 over 64, minus 2 times r times 7/8. Here we have r squared on both sides of the equation number 1, so r squared will get cancelled, and we left in this side, we left only with 625 over 64. And here we have minus 2 times 25 times r over 8. We divided both the numerator and the denominator of this expression by 2, and minus 2 over 2 is minus 1, so 2 will get cancelled, and we left only, in the numerator we left only with minus 25r, and here we divided also the denominator by 2. 8 over 2 is 4, so in conclusion this expression equals to minus 25r over 4. Then it is equals to r squared plus 49 over 64. Here we have the expression of minus 2r times 7 over 8. We divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is 1, so 2 will get cancelled, and in the denominator we left only with minus 7r, and in the numerator we left only with minus 7r. In the denominator we have 8, so we divided 8 by 2, and we get 4. So in conclusion, this expression equals to minus 7r over 4. We multiplied this equation by 64, equation number 1 by 64, and we found out that 625 times 64 over 64 equals to 625, and here we have minus 24r over 4 times 64, it is actually minus 64 over 4, that is minus 16. So this expression equals to minus 16 times 25r. After we multiply it by 64, it is equal to minus 16 times 25r. And here r squared times 64 equals to 64r squared. And here 49 times 64 over 64 equals to 49. And here we have minus 7r over 4 times 64. It is equals to minus 16 times 7r. This is minus 16 times 7r. So here we have 625 minus 16 times 25r equals to minus 400r. And we have here 64r plus 49 minus 16 times 7r equals to minus 112r. Okay, here we added 400r to this equation, equation number 1. We have here 625 minus 400r plus 400r is 0. So here we have 64r squared plus 49 and plus 400r minus 112r is plus 288r. So in conclusion, we found out that 625 equals to 64r squared plus 49 plus 288. We subtracted 625 from this equation, equation number 1, and we found out that 625 minus 625 is 0. So here we have 64r squared plus 288r, and 49 minus 625 equals to minus 576. So in conclusion, we found out that 64r squared plus 288r minus 576 equals to 0. We divided this quadratic equation to 32 and found out that 64 over, so here we divided this equation by 32, and 64 over 32 is 2, so this expression equals to, in total to 2r squared. And here we have 288r over 32 equals to 9r, and minus 576 over 32 equals to minus 18. So in conclusion, we got the quadratic equation that 2r squared plus 9r minus 18 equals to 0. In this quadratic equation, the coefficient a equals to 2, the coefficient b equals to 9, and the coefficient c equals to minus 18. And the variable that we are looking for in this quadratic equation is r. This is to say x equals to r. And the general formula to solve out a quadratic equation is x, that is equal to minus b plus minus square root of b squared minus 2 times 4 times ac over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. Okay, in our specific quadratic equation, the variable that we are looking for is r, so x equals to r. So we substitute x by r. So r, according to this quadratic equation, r equals to minus b. B equals to 9, so minus b is minus 9, plus minus square root of b squared. B equals to 9, so b squared equals to 9 squared, that is 81. Minus 4 times a is 2, and c is minus 18. Over 2a. A is 2, so 2 times 2 is 4. So r equals to minus 9 plus minus. We have here 81. Inside the root we have minus 4 times 2 is minus 8. Minus 8 times minus 18 is plus 144. So in the Inside the root we have, in conclusion, 81 plus 144. So here r equals to minus 9 plus minus square root of 81 plus 144 over 9, over 4. Over 4, of course. Here 81 plus 144 is 225. So inside the root we left only with 225. So r equals to minus 9 plus minus square root of 225 over 4. The square root of 235 is 15. So in conclusion we found out that r equals to minus 9 plus minus 15 over 4. So here we will have two solutions that are possible for r, that is the radius of the small circle. The first solution is r equals to minus 9 minus 15 over 4. Minus 9 minus 15 is minus 24, and minus 24 over 4 is minus 6. So we found out that r, that is the radius of the small circle, it is equal to minus 6, that is a negative number. But because of the fact that r is the radius of the small circle, that is to say it is the length of the radius of the small circle, and as a length it must be a positive number. R is a length, and as a length it must be a positive number, so r can never be equal to minus 6, that is a negative number. So we cancel this solution, and we left only with the second solution, that r equals to minus 9 plus 15 over 4. Minus 9 plus 15 is 6, so we have here 6 over 4. We divided both the numerator and the denominator on this side of the equation by 2. 6 over 2 is 3, and 4 over 2 is 2. So in conclusion we found out that r, the radius of the small circle, the radius of this small circle, it is equal to either 3 halves, that is to say 3 over 2 units, or in terms of numbers it is equal to 1.5 units. I repeat again, r, the radius of this small circle, equals to 3 halves, or in terms of numbers it is equal to 1.5 units. Okay, thank you very much.